Presentation is going to define what the Cauchy sequence is and illustrate the importance of the values of M and N in the Cauchy sequence. But first, let's just review quickly what a Cauchy sequence is. A sequence piece of N of points is said to be a Cauchy sequence if, corresponding to any epsilon greater than 0, a number capital N, depending upon epsilon, can be found such that the distance between 2 points, P sub N and P sub M, is less than epsilon whenever both M and N are larger than capital N. In other words, the limit of the points P sub N minus P sub M as M and N approach infinity equals 0. If we were to graph this concept, the Cauchy sequence says that the convergence of a sequence will occur past this number n if and only if all the points are captured within plus or minus an epsilon, and that M and N are unrelated and independent of capital N. Now, one problem is that we cannot, these points M and N are unrelated and independent. If we were to make these points consecutive such that the limit of a function for x for n plus 1 minus x sub n, in other words, for consecutive points, if the limit for n going to infinity, the differences in those 2 points was equal to 0, that is not sufficient to meet the requirements of the Cauchy sequence. And as an illustration, if we took the function, the square root of n, and we used consecutive points, these consecutive points, as n approaches infinity, would equal 0. Although x sub n is actually unbounded and a divergent function. So what was being illustrated in this presentation is the Cauchy sequence and the importance of the points n and m being unrelated and independent, so that all the points of the sequence are captured within plus or minus epsilon and meet the criteria of the Cauchy sequence.
I have no idea.